Well, thanks for coming and joining me in my shop as I go the next step on this Kalmar Electrohome console receiver, which is going to be doing the AM alignment. So let me switch it on here and make sure it's warming up. There we go. Good show. Okay, so I have all my equipment already connected to the radio. And we'll be using the signal generator set to 455 kilohertz. There you can see how it's connected in. The oscilloscope is fed in through this capacitor right into grid pin 7, which I think is the grid of the mixer tube. And then we're watching a voltage coming out of here at a point called, I think it was E, on the radio here. Quick check here. Point, that's right. Point E, AM audio output. Okay, so I think my meter should be set to AC over there. Switch meters once we get going here. So let's see, put it on. I'm going to leave it on DC right now for the moment being. I thought we were going to be monitoring a DC voltage, but in fact it's just the audio output from the radio. Now the main purpose of doing the alignment this time around is to verify that the capacitors I've put on the IF transformer that I took out and fixed are suitable, and that we can peak the IF coils roughly in the middle of the travel of the slug. So we'll have to just see how that goes. I'm just going to follow the procedure, and when I get to that IF, we'll find out what happens. Let's turn it up a bit here. That's not quite what we should be hearing. Let me just make sure it's on. It's on AM. Gesundheit. We're off to a big start here. Oh, I've got the signal, the input signal very low, so I'll turn it up a bit here. There it is. And we'll just double check. I'll just sweep back and forth a little bit on 455 and just listen to it, and maybe we'll watch here. It's going to be very hard to see on this meter unless I turn it up pretty loud. There we go. Sounds pretty good. I'd say it's peaking at 457 myself by ear. The meter here, I think, is responding to this terrible hum that's coming through here. I'm going to have to get rid of that hum. Okay, got ground connections here. Now let's take off the signal generator. The hum is still there. Disconnect the voltmeter. So why would my voltmeter be putting a hum into the radio? Okay, I think I'm going to switch voltmeters in any case. Because this one's just not sensitive enough to do what we need it to do. Probably the hum will disappear with it. Okay, so I switched meters over to this really great output meter, and you can see it's a little bit upscale right now. And, see. Pretty sure the volume has no effect on that. Yeah. No effect on it because we're picking this off coming right out of the receiver before it gets to the amplifier circuits in the radio, in the receiver. And now I'll verify that this for sure is the signal. I'll turn up and down the percent modulation, which will increase the amount of sound going to the radio. We'll just see if the pointer does go up and down, just to be sure. It's at 30% right now. So we'll watch the... Yeah, you can see it go up and down. There's no hum. Okay, so we're at 30%. Quite low on the meter here. But I think that'll still be okay. We'll still be able to do the alignment. And I could boost the signal going into the radio. That might move it upscale a little bit. There we go. Okay, I think we're all set to go now. Don't know why my other meter was humming like that. That's kind of something I'll have to look into. That's the problem with doing vintage radio work with vintage equipment. Well, you got your hands full. There's no telling where the problem lies. Okay. The right sheet here. 400 cycles per second, 30%. That's how we're set on the signal generator. Dial pointer at 600. I'm not sure it really matters that much, but there it is at 600. DTVM to point E, what's this? Nominal sensitivity, 4,000 microvolts for 20 millivolts output. Oh, that's interesting. I can actually measure this and read all this stuff. T10, second AM/IF. So of course we're starting on the second AM/IF. Second AM/IF is the one at the back of the radio, near the outer edge. Back of the radio. Back of the radio, near the outer edge. That's this one. Well, that's the one that I changed. Right away we're starting with that. Is that true? Is that really the one? Yep, that's it. So right off the bat, the first thing we're going to do is try to align the IF that I changed. I still have the two capacitors sticking out here. Everything's a little bit temporary. Let me go in from the top here. So it's this one here. There's the first slug. Can't get my way into the second one, so we'll just do the top one from here. A second here. Holding my hand still. Watching the meter. Slug won't turn here. Okay, let me put the stiffer part of the tool in. There it goes. It's kind of stuck. Coming up. There's a peak. Very good. Now, I get to the bottom slug. Let's see if I can get through it. Get to it from the top. It's just that much better. Slide through the first one. See, I think they're close enough together and they're aligned in such a way that, oh, I got it through. I got it through. Okay, now. I'm just feeling my way back here. So I'm right through both slugs. I'm pulling back up into the lower slug. Okay, I got it. There we go, watching the meter again. Oh, guess what? I'm at the limit. You see, it was coming up all the way. I'm going to turn it back down because I don't want this jammed. So, wrong size capacitor. Can't peak one of the coils. Okay, so that's going to lead to a little bit of experimenting here on this. First of all, which one is it? Move in for a little bit of a closer look here. The two capacitors right here. Everything's kind of tack soldered in there, so if I yank on anything, we're going to know it. So how am I going to tell which one is which? Which capacitor is on the lower coil and which one's on the upper coil? If I'd thought far enough ahead, I would have made some notes about this. Probably look back at some old videos and figure it out that way too. I think I'd rather do some kind of tooly thing here. Okay, so I'm just going to touch the leads and watch what happens to the output meter here. Which I'll just turn this like this. Put this down like that. Kind of keep an eye on both items here. So I'm just touching it just to see what happens. Interestingly enough, that's going up. Why it goes up, I don't know. Let's see. That goes down. Well, maybe I'm in luck. No, that goes up. What I was thinking was, I've got one of them tuned, so if I do something to disturb it, its tuning will go down. Just turn the volume down there. And I'll get a drop in the signal. And the other one, if by some magic, touching it with this thing somehow improves the tuning, I'll see an up. Well, that's a good idea, but it didn't work at all. Maybe there's a hint in the schematic here. Which I'm now taking a look at. Second IF, second AMIF. It's T10 here. Okay, so there's a 6AV6 detector tube, 6BA6 IF amplifier, and here it's going through this T10. This is the guy. Wait a second here. The horses. Okay. Okay, let the horses go again. Just realized there's actually 5 pins, and I was wondering if I'd connected the 5th pin. Wow, I gotta stop and think about this a little bit. I forgot something here. I forgot about this third capacitor here. yeah, I gotta think a little more about this. Amazing the radio works as it is, but most IFs have 2 coils, 2 capacitors built inside of them. This one has a third, and the third one, currently the whole thing's running without the third one at all. This is just shorted right in here. I don't know if you can really see that or not on camera. Yeah, I totally forgot something here. Okay, gotta stop and think about it. The joys of doing this work. Okay, so now we're looking at the 2 capacitors here. Just wiggle the camera here so you can kind of get a cheap 3D view of things. Okay, so these 2 capacitors are in question, and which coil is which on the IF transformer, and I found a little bit of circuit tracing here. And so this tube up here is the 686, and the tube over here is the 6BA6. This is the last IF. This is the detector tube, the 686 up here. So we're looking at the circuit diagram and tracing back from the 2 pins. Okay, so I was able to determine that this is pin 5 and 6 here on the rectifier, on the detector, and it's connected here. So this pin becomes pin 1 on the IF transformer. Okay, the other side of that coil is pin 2. This is pin 2 here. So this is 3 and 4 on this side. 3 and 4, 4 and 3, I'm not sure. And this one right in the middle is hard to see. There's one right here in the middle. Give me a better pointer. Okay, so there's this one right in the middle. This is the one that I want to cut the wire that's currently connected. It's not doing anything anyway. And put a capacitor from this terminal to this terminal, and that will be the replacement for this capacitor right here, this little capacitor here. Basically I'll be connecting it from this line in here. This is just grounded to the chassis here at this point, back to the secondary IF coil and capacitor arrangement. What's that capacitor doing anyway? It's going to ground. This is where the audio is taken off on the radio, and you really don't want any RF left over here. So that capacitor is just shunting any RF that might be left in here to ground. So this is a pretty high impedance circuit here. The resistors are big. This is 390K. This one down here is 2.2 megohms. So it's got to be a small capacitor, because if I put in a too big of a capacitor in here, it's going to bleed off some of the audio out of this high impedance circuit. We don't want that to happen. So, you know, all 3 of these capacitors that were integral to the transformer were built the same way. They're all going to be similar in capacitance. So I've replaced these 2 already with 180 picofarad capacitors. Something like 100 picofarads here is probably just fine to get this guy doing its job. And the interesting thing too is, if I don't put in the capacitor, like right now, the way it's operating, and some RF is running around in here a little bit, we can't hear it, and I'm really not sure what bad effect it would have on the radio, if anything that we could hear. Maybe nothing. You can't hear any bad effect, but a radio engineer would know enough that I really don't want any RF passing through here. Maybe that RF is going to go in the radio and couple its way back to something else, and you're going to get something going on that you don't want. So drain off the RF here with this little capacitor. So that's what I got to do. I got to install that little capacitor there, and then carry on with the alignment again, and I'm sure I'm going to find one of the two 180 picofarad capacitors is also not the right size. But that's for the next step after this one.